All right, this is a linear combination problem. Something you should have had last year, but most of you did not.
Because the teacher did not teach us very well, I guess.
Well, I don't know about that. She was a good teacher. But you just didn't get covered this, I don't think. Linear combination, right?
No.
Covered linear, but linear combination.
No.
All right, so we need to cover it because it will be on the test. Okay? And so what I do here is I got to take into consideration a couple of things. One, we know that this is perpendicular because it says it is, right?
Yes.
And so it says if it is perpendicular, then what does x and y equal? Well, what does it mean to be perpendicular? How many degrees is that? Because remember, these, like you said, are parentheses, degrees, right? So, how many, and somebody said 90. So this is 90, and this is 90, right? So basically, 2x, right, Matt?
Yes.
2x plus 10y is equal to 90. And in the same aspect, 5x plus 5y is equal to 90. Correct?
Yes.
Now I'm going to show you the most fun I ever had in math.
You created a baby.
I teach this linear combination, and that's all I teach. I don't teach subtraction and all this other stuff, substitution a little bit, but basically I put it all in a combination, right? Or it's called addition. Okay? And so what I want to do is I want to make one of these the opposite of the other. So what's easier to make, to make 2 and 5 go into the same number, or 5 and 10 go into the same number? 5 and 10, right? So what does 5 and 10 both go into? 5 and 10. What do they both go into? What number?
1. I'm just kidding.
20. They both go into 20. Do they both also go into 10? Yeah? 10, right? 5 and 10, yeah, greatest common factor, right? So, or lowest common multiple, right? So 5 and 10 both go into 10. So I could make it so they go into 20, because they both go into 20. But that's a little overkill. We don't really need to go that much, right? They both go into 10. 10 goes into 10 one time, right? So it kind of makes it easy for me. I can say, hey, what times 10 is 10? 1. Okay? And what times 5 is 10? 2. Okay? Now, are they opposites? If I multiply by this, they'll both be 10, but will they be opposite? Opposite meaning one's a positive 10, one's a negative 10. No. So I need to make them opposites. So, how about a negative 2? Right? Because in this way, I don't really change this at all. This just equals 2x plus 10y equals 90. Right? But with this one, it changes everything, right? Changes everything. Negative 2 times 5 is negative 10x. Negative 2 times 5 is negative 10y. Negative 2 times 90 is negative 180. Does that make sense? Okay. And so, what I do is it's called linear combination. Okay? Linear combination. And what it's for is combining these two things. I'm just combining them. That's why I like it. As long as I make them opposites, when I combine them, one of the variable goes away. It disappears. In this case, it's the y. Right? What's great about that is that when I add these up, I get negative 8x equals negative 90. Right? And so what do I do with that? Divide by negative 8. Okay? And so, what does that equal? What does x equal? We could do our short short division again, remember? 8 goes into 9 once with 1 left over. 8 goes into 10 once with 2 left over, right? 8 goes into 20 2 times with 4 left over. And 8 goes into 40 5 times. So that wasn't too hard. We had to go out a little bit, but 11.25 is the exact number, right?
No boo.
Then, what we can do is plug that number in and find y, right? But that's not a fun number to plug in. I mean, if it were 11 or 12, that would be fun, right? But that's not too much fun for me. So there's another way we can do it, okay? I can do that and plug it out and chug it out and do all the math, use my calculator, blah, blah, blah.
Bless you.
Or I can change these again. I can just change these so that they fit. Does that make sense? So I can just take 2x plus 10y equals 90 and 5x plus 5y equals 90. Okay? And I can change the 2 and the 5. So what number does 2 and 5 both go into? 10. So how do I get 2 to become a 10? Times by 5. And how do I get a 5 to become 10? Times by 2. Are they opposites when I do this? No. So I need to multiply one of them by a negative. Okay? So I'm going to choose the top one just because, I don't know, I did the bottom one last time. I don't know why. I like it on top. So I go like this, and I say negative 5 times 2x. And I get negative 10x. That's x. Okay? Then I say negative 2 or negative 5 times 10y, and I get. Okay? Then I say negative 5 times 90, and I get negative 94. What's 9 times 5? 45. Add 0. 450. Okay? Okay, back to 6th grade. Boom. Gotcha. Kind of like that. Okay. So, then I do 2 times 5, and I get 10. Right? And then I do 2 times 5, and I get 10. And then I do 2 times 90, and I get 180. Right? And then I do the math. What's the math? Combining. Good. Yes. Right? Adding them up. So these go away this time. And I'm left with the y. Okay? And so this is negative 40. So 40y is equal to, and then that's a negative, so that's 370 minus 1, so 270. Right? Did I do that right?
270.
Okay, then I divide by 40, which in essence means I divide by 4. Again, back to 6th grade, just get rid of the zeros. It's easier, right? So then I got negative 4 divided by negative 4, right? And I get y is equal to it's another one of those quarter numbers, right? So again, we gotta go, okay, 4 goes into that how many times?
7.
No, almost. 6? Yeah, with 4, so that's 24, so 3 left over, right? And 4 goes into 30 how many times? Again, with the 4 goes into 30, 7, right? Right? And then that's 8 with the 2 left over. And then 4 goes into 20 5 times. And so your answer is they are perpendicular if x is 11.25 and y is 6.75. But now you got to plug them in and figure it out. Right? Now you got to go, okay, plug it in. So 2 times the x, or 11.25, plus 10 times the y, or 6.75, and we've got, that's 2250, and that's 6750, and so that's 50 and 50 is 1, that's 68, 78, or 68, 69, 70, 70 plus 2 is 90, right? So we made sure that it works, and it does. They are 90. Okay? So this is what y has to be, and this is what x has to be for them to be perpendicular. Ta-da!